usually turn the 2D plates into large 3D shapes using aluminum extruded tubes. So you can see a lot of it all over the place here, where like on the front there's a lot more complex version of a plate that we just made, and it's stitching together several pieces of aluminum tube. You can see, so for example, this tube is 2 inches by 1 inch across, and we kind of put a bunch of holes into the right place, and then it has plates on the outside. There's other places where, for instance, there's 1 inch by 1 inch tube, like in these ramps, and as well as in the drive base. And typically, when we're early in development, we don't know exactly where things are going to go. We'll put this standard hole pattern on all of the tubes. So let's learn how to make these tube structures and efficiently put all these holes in. So going back to the document we had before, we're actually going to go plus sign down here in the left and insert a new part studio. So now here again we're at this at the blank 3D canvas, and I'm going to rename this one to be drive tubes, since that's what I expect to be drawing. And we'll select this top view again and go back into sketch mode. So in this case, the sketch is actually pretty simple. We just want to draw, we want to start with the rectangle of the tube. So we're going to use that rectangle tool up here again, and we'll plop that down, and then we'll hit D for dimension. And let's do the front tube that's on the drive base first, and that's a 2 inch by 1 inch 1/8 inch wall. So we're going to put that 1 inch in here, and I happen to remember that the tube on the front of the robot is 27.75 inches long. Now if I wanted to look at one of our old models and remember what that was, I could go over here, and I know that the tube in front, for instance, is right here, and if I select an edge on it, you can actually see down in the lower right that it gives me a length. And in this case, there's only one dimension of measurement, but it can actually give you many more dimensions here. So like if I wanted to know, this is actually going to come up in a minute, so let's do this to remember. If I wanted to know how much space there was between this edge and this tube over here, like this flat part, then I could select these two things, and if I go into the details, you can see a lot more information about these dimensions. So in this case, actually, it's just selecting the perpendicular distance, which you can see as I highlight is 2.37. But it could also tell you things like different colors. Like in this case, it's red along the tube because it's in the X direction. As you can see, that matches the colors up here of the cube. Okay, so let's remember that one as well, 2.375. That's actually how much space on this robot you need for the pneumatic wheels, which is a little bit bigger than these wheels. Okay, so back to our test file over here. We actually have all the initial sketch dimensions we need, so we hit green check mark. And now we're going to turn it into a 3D shape. So we select that sketch and Shift E, or just hit the extrude icon. So the default size, 1 inch, looks like that. So basically, if you were doing 1 by 1 extrude, you could use this 1 inch depth. But since we want 2 by 1 for the front, we'll do 2 inches. Okay, so that makes the rectangle a little taller. Right now, though, you just have this. This is actually a solid block. So to tell the CAD program that we want to use tube, we're going to use the shell command. And now it's asking us, like the other tools, we need to fill the blue box content here. So we can select this face on the end, and you can see that it digs out the internal of the part, but it doesn't go all the way through because it's calculating like the minimum wall. So if we just swing around to the other side of the tube, select that, now we've got all the way through. Okay, and we do need to adjust the thickness, so you can see there's a shell thickness field. We're going to use a 1/8 inch tube for this part. So we select that, it gets a little bit thicker, and then we click OK. So to put that whole pattern down, we're again going to use Sketch, but this time we will use it on the face of the part. So we can select this face on top, hit Sketch. So now this sketch is specific to this solid object. So I'm going to hop over here to the top view again, and we're going to use our circle tool again. So center point circle, hotkey C. We'll just draw that in, and then we'll do dimension D to put in our 0.192 inch size, and also to put it at a 1/2 inch from the edge. So just zooming in a little bit so I'm specifically not using the angled dimension, I'm using the perpendicular dimension. Okay, great. So now, like the gusset, we can make this more efficient by using the pattern tool. So I'm going to select a linear pattern over here, hit that, that circle, and you can see that there's blue suggestion circles here. So let's change it to 1/2 inch spacing. And then we actually want a few more than 3. So since the bar is like 27 inches, you want like 54, 55 holes. And it doesn't fill in all of the ones in between, but you can see that it draws like the last few. So that's the number of holes that we want, and then we click green check mark to accept, and you can see that now we have a lot of black holes. Okay. This is actually all we need on this sketch, so we click green check mark, and now we want to tell it how to use this. So what we could do is select each hole individually. In SolidWorks you would have an extrude cut tool, but in here you just have the regular extrude tool, and then it has extra details in here, like you could use solid remove and then select, for instance, you could select an individual circle and it will drill one hole. But to be way more efficient about this, we're actually going to select the entire sketch, since all it has is circles on it. If we do extrude remove, it will drill all of our holes at once. So you might notice though that it's only drilling halfway through the part. That's because it has a depth set at 1 inch. We could change that, or we can change the mode to go through everything. So if we change it to through all, now you can see that there's holes in both directions. Okay, and we just click OK, and now we have half of our holes. So let's do the other face. We do the same thing, select there, select the front, hit sketch, and now I can jump to the front view. We put, like before, we can do, circle tool, put this in place, we can dimension it, and we'll just put in that 0.5 inch from the front. So this is picking up the dimension in 3D of the shape. To reduce the number of dimensions in the overall part, I actually want to connect this circle to the ones on the top. To do that, we could use a constraint like we did in the sketches. So I can select the vertical constraint. The only problem is you can see that there's nothing to attach it to. So if I click here, like I want to connect to the circle, then it basically doesn't do anything. So we need another sketch to attach it to. And it's actually possible to get back to the sketch we used earlier. So you can see it's grayed out in the feature tree. But if we hit the little eye next to it, you can actually see that we get those items back. So now if you hit the vertical, you can select the point that's inside of one of these circles and then hit your point over here and it snaps into place. Okay, now like before, we give it a pattern. We change the pattern width to be 1/2 inch. If I remember right, we had 55 holes. And we will also set the 2 direction pattern here. So we needed 3 holes at 0.5 inches apart. And now you can see that it fills in the entire front pattern. Perfect. So we accept that. And like before, we take this, we extrude, solid, remove. We can go through all. And now we have our bar. So I'm just going to shut off that sketch too. And now we have our extruded bar with hole pattern. So this is nice to have this one bar, but it's much more interesting if we're able to draw an entire structure at the same time. So Onshape actually lets us do this pretty efficiently. So let's go back to our first sketch. And in here we defined, so now we're going like way back in time, which is one of the features that this lets us do. And we defined this one rectangle, but let's say we wanted to draw more than that one bar. So I'm going to throw in a couple more pieces of drive base in here. So let's say that we also draw our side tubes, and then we draw, so I'm actually going to use, you can see that it's a little bit interactive on the constraints here. If I highlight to this dot and then I go over, it's actually telling me it's going to fix this point vertical and horizontal. So I'm going to do that. And now this is our back, this becomes our back tube right here. And I'm actually going to draw a few more items in. Maybe I'll draw them off to the side here. So these are actually going to be kind of our wheels. So we have a picture of where they are. And again, I'm going to use this, the dash line here. We can follow this down. And then I'm going to put another one up here. Great. So let's add some dimensions in here. So the endpoints of this are already fixed because they were attached to the bottom. This one, I happen to know that our drive tubes we like to make 1.5 inches thick. If you remember from earlier, we measured the distance. So I'm just going to cancel that and go back in. Earlier, we measured the distance from here to here as 2.375 inches. So let's just put that right in here. And we still have a couple blue bars left. So what we want to do here is actually, let's fix the front and the back tubes to be the same thickness, so the same type of tube. I can use the equal constraint for that. So that will make these, so let's make this line equal length to this line. Great. I'm actually not sure. Oh, right. Not sure why those lines are still blue, but that's just because the length of this tube is not set. So because there's a total size for the drivetrain length, I happen to know that this is actually supposed to be 30 inches long. Okay, and we can also prove that that's how long we want it to be because we could draw hypothetical wheels off to the side, for instance. So if you were going to use this to be like a master sketch that showed how your geometry works. So for instance, I'm going to dimension this wheel. We usually use 6-inch wheels. And then let's say I don't want to dimension those again, so I'm going to use equal to say that this length is equal to this length, and this length is equal to this length. And let's throw in one more, which is that, you know, in past years, the length between our wheel axles has been about 11.5 inches. You can see that it's actually not really letting me select the middle of this right now, and I don't want to calculate the distance between. So what I'm going to do is actually I'm going to go L for line, and if you use the line tool, it does snap to the middle point here. So I'm going to draw the midpoint across these actually. So I did escape to cancel the tool and then L to get back in. And I think if you actually just hit L, I guess you have to hit L twice. Okay, so now I have all these lines. None of these are actually going to be real geometry, so I'm going to select it all and then right-click Construction. Great. And now I can put that center-to-center distance in here. So it's roughly 11.5 inches. This would, of course, be adjusted a little bit based on the chain length between the two. So we have a way to calculate exactly the right distance. Oh, and of course, this doesn't actually have a thickness to the wheel. So a hard wheel is about 1.5 inches thick. So I'm just going to put that in for a placeholder. But what we can see immediately as we drag this around, and you have to, so it only lets you drag in one direction at a time. So if I do this, I can put it roughly in the place here. And then if I drag this, over, then I can kind of tuck it in here. So you can see we don't really have a lot of room on the ends, but there's a little bit. If we wanted to make sure that this is definitely in the center, I could use the line tool. And then I can go over here and again, see I can select the midpoint here. And then I can actually hook it up to, you can see it's automatically putting in a coincident snapping to this line. I'm going to make this construction as well. So right-click Construction. But let's say I wanted these 2 points to line up across. I could then go here and slap in a horizontal constraint, and it snaps it into being right there. Great. Okay, so let's take these tubes and, let's take this drawing, and we're actually going to turn it into multiple pieces of extrude. So let's leave the sketch. When we leave, we can see that, okay, so it's actually created, that whole thing into different tubes. So let's go and undo that actually. So I'm going to edit the very first extrude, X out the contents of the blue box, and instead of selecting the whole sketch, I'm just going to select this one rectangle here. Okay, so now if we do that, it's 2 inches thick. We click the check mark. It's just going to go back to being a single tube. From here, I need to create more tubes. So we're going to unhide that first sketch again. And then we can go back to the extrude tool. And a key part here is we're going to do solid new. And then if we select this side piece, now it's going to make a totally new part. So again, so we want it to be 2 inches thick. And then we select OK. Oops, sorry, it must have defaulted back to, see. So this is the difference between add and new. So it defaulted back to doing an additional piece. So you can see that then they're the same color, and it's basically one solid part. But what we actually want is, I'm going to double click Extrude 4 to edit. We want solid new part. and you can see it's actually a different color. And then we check mark, and now we have two separate parts added down here in the part window. We can actually go and, if we wanted to, we could also extrude the back bar. So we could do solid new part, give it that 2 inches of thickness, and now we have 3 discrete bars, and we could give them separate names down here. So we could do, your front tube. Part 2 is your. I'm going to right click rename. This is like your well, it's actually, if that's the front and you're going down the road, this is actually your drive right tube, and this is your back tube. Okay, great. So just like the sketches, you can use this part area down here with the little eye to hide and remove parts. If something's in your way imminently, you can also use the shortcut Y to get rid of that. And then you can bring it back over here. I needed to hide those 2 parts because I actually need to see the end of this so that we can do our shell action. So I'm going to, just like that last one, I'm going to, you kind of got to do all these operations per solid one by one. So we're going to make that also an 1/8 inch thick. Great. And what we can do is, because all these things have different names, we can actually group a bunch of items together. So we know that everything from here to here is all part of this front tube, right? So we can select them all. So you can, I'm going to hit blank space to unselect. So we know that this through here were all part of making that front tube. So to clear things up, you can click and then shift click at the end of your selection, right click, add selection to folder, and you can make this all part of the front tube basically. Okay, so now it'll kind of hide those items, and we can move on to making this side tube. You can also kind of like drag and drop this stuff around later. So it's very easy to organize all of your different features. Just like before, we can go in here and we can put our hole patterns in. So we can do sketch, and we're going to go back to the top. So now we use our circle like before. We give it a dimension, and we're also going to dimension it onto the part itself. So this is adding that 0.5 inch here, and adding that 0.5 inch from the front. Okay, and then we're going to do the linear pattern again. Set our spacing to 0.5 inches. In here we only actually want 2 across, so we're going to do 2x. And then in the vertical direction, it was a 30-inch tube, so I think that means we need 60 minus 1, so 59 holes. And now the spacing appears, so we can change the spacing here to 0.5 inches. And if we zoom out and look at the top, the holes are in the right place. So we hit left mouse button to keep them. Great. So that should be good for the top holes. I want to turn that front tube back on, because one of the things that you may notice here is, because the front tube is kind of an odd number, now these holes don't actually perfectly line up. So we can go back and adjust that if we go to, remember we defined this in sketch 2, and it was important to draw sketch 4 in order to get to this, but this means that the gusset plates that we drew wouldn't line up, and this is actually a problem that we faced lining up these tubes for the competition robot in 2019, and it helps to define all of them together so that we can fix issues like this very quickly. We can actually link these together if we go to Sketch 2, and we're going to edit that here. So I'm going to delete actually, one of the things we need to do here is that we would actually need to define the side tube. We actually need to define the front tube later. So let's complete our extrude of these items. So let's do that extrude remove through all. Great. Okay, so now we have those top holes going all the way through. And the reason I paused there is because we're going to rearrange our feature tree a little bit. So extrude 5, let's just tuck that into the end. Everything that's related to this side drive tube, let's add these selections to folder, and we're going to do drive right tube. Great. And the reason I wanted to add this to a folder is I'm going to bring this whole thing up above the front tube. So it regenerated everything. It finished the little spinny thing, and it all came back the same. The reason this is important is because we need this drive tube geometry to exist in history first if we want to base the front tube off of it. Part of what's so powerful about these programs is that you can kind of drag and drop the order of operations around, and as long as you're careful about how you put it together, it often works. So now let's go back to Sketch 2, and if we double click this, we're now editing the sketch. I'm going to snap, actually I'll just move a little bit to the side. What I'm going to do is delete this dimension here. Okay, so now all of our circles have gone blue again, and the reason why is because they can be moved from side to side. What we want to do is force these holes to line up with these holes. In order to see where those holes are, we need to go back to this sketch here that defines them. So I'm going to turn this sketch on. Okay, so now we can see all of our little points, right? And then we can define in our current sketch 2, we can define that I think the right constraint here is horizontal. So we want this to line up with this. So I'm going to click here and then click here, and everything is red because it's not constrained correctly. Well, it's over constrained. That means it's not able to solve it. So I'm actually going to undo that. I think the correct answer was the vertical constraint. So we're going to select here and select here, and now it snaps into place. Everything is black. That should mean it's fully solvable by the computer, and it's guaranteed to line up. So we hit the check mark, everything regenerates, and we get our holes back. So the reason this is really powerful is because if we wanted to go into the master sketch here, and let's say that we needed to move this line over like to actually be like 2.5 inches, and then we leave this sketch, it will take a minute to regenerate everything. But now this is moved over, and all of the holes are lined up correctly. So if we were still in the design phase, our placement would be correct just by moving those over. Of course, there's, oh, actually, it actually is filled correctly at the end. Okay, but we're actually going to undo that change, and you'll see that it just shifted over. Continuing with the drive tubes, we need to, so we kind of have this idea of where the wheels will be, but we need to add bearing holes for the axles, as well as mounting location for the gearbox and the hole pattern on the side. Since we moved the drive tube definition up here, and we want to group the things, the new actions together, we can actually tell the program to start drawing from a time that's farther back in history using the rollback bar. So that's this kind of thick bar at the bottom here. We can just click it and drag it up to inside of this folder that we created earlier. So now some of the stuff on our screen will disappear, but we're effectively editing an old point in time. So now we can go back to that mode where we start to draw on the side of the tube. So we'll go into sketch mode on the side of after selecting the side of the tube. And I actually first want to draw so I'm going to jump to the right hand view, and I first actually want to draw in our axle locations. So I can use the hypothetical drawing we made on the ground to pick the center point and kind of put it in here somewhere. Again, I'm using the circle tool. I clicked the center point, and then I click again to make the circle. I'm going to give it a dimension. The outside diameter of the bearing is 1 1/8 inch, so 1.125 inches. And then if we want to actually take that dimension, I believe I can copy and paste this circle. That actually creates a copy of the dimension. But in this case, well, we'll do that again. We'll paste one more circle. But instead of having 3 copies of the dimension, I'm actually going to delete that. And we'll set up an equal size, so that's capital, or it's E, between this one and this one, and this one and this one. So another technique we can draw in here is usually for a 6-wheel drive West Coast drivetrain, the middle axle is actually just a little bit lower than the other ones. So I'm also, while we're doing constraints, I'm going to set up a horizontal from here to here. And then we're going to set up from here to here. You can see just for a little bit in here, it lets us do that perpendicular vertical dimension. And I'm going to make this, well, okay, so this will be really small in real life, but let's actually set it to something kind of large for now. And the reason we're going to do that, so you can see that they're both up here, is now we're going to draw in our dimension for the chain centers. So from here to here, we're actually going to use the angular dimension. See how it snaps right there to an angle? And let's pretend that our chain calculation told us it should be 11.5 inches. It probably won't actually be a round number like that. Okay, we're going to do the same thing here. Insert that angled dimension, 11.5 inches. And now we can change our drop center back to something more reasonable, like a 1/16 of an inch. Great. So now it looks almost flat, but you know that these 2 dimensions are actually angled. And we can set up our nominal center to be in the middle of the tube. Actually, we can set the other 2 to be the regular size, so we can actually subtract our 1/16 of an inch. And it will actually do math as long as you don't put units in. Oh, I see. Or it'll insert the parentheses for you. Okay. Great. And now that everything is black, it should be constrained. One extra bit that I'm going to add in here is actually, let's also draw in the gearbox mounts. So I happen to know that it's going to consist of 2 bolt holes, essentially. So let's draw those in, and don't remember the exact size of them, but let's guess that they're gonna, let's just guess that they're gonna be 1/4 inch holes. And let's set, actually, you know what, we don't actually have to guess on that part. So one of the great parts about the Onshape library is that we can actually, I'm just going to jump over to this other tab, and actually I'm just going to go to the home page, and let's go look for the real gearbox. So a lot of these things are so I'm going to select public documents, and then a lot of things are in the MKCad library, which is from another team that publishes a lot of parts. And so if you look for MKCad, you get all these different categories of parts, and the one that we want is probably in gearboxes. So I'll open that, and I think I had looked at this before, so actually the document I want is here, CIM Ball Shifter with 3rd stage. Okay, so we look at it here, and so this is our, you know, if we start to use the dimension tool, this is our 1.124 inch bearing hole that we just put in, and these are the 2 bolt holes that we really want to know. So I'm just going to select the bolt, hit Y to hide that real fast, select the other bolt, hit Y. And the reason I'm doing that is because now I can see the hole that they made in the plate. So if we select this, you can see that the diameter of the hole is 0.26 inches. So we're going to remember that to put on our system. And also, if we select this circle, and then we go down here to the measure details and expand it, you can see that it gives you a 3-dimensional measurement, exact measurements. So the holes are, so the red axis is X, so they're lower than the center of the bearing by 0.18 inches, and they're 1.975 inches. So this part's a little weird. I happen to know that if you go from hole to hole, which is a dimension they give you on the data sheet, this is actually 4 inches, but then for some reason they're not actually centered from here to here. This is like 2.051. So let's just draw it as 2 inches from here to here to here. But the key part that we pulled off of here is, I'm just trying to select nothing on the screen here. It's not cooperating. Okay. Trying to select blank space. Okay, so if we select from this circle to this circle, we can see that we need to put in a drop of 0.18 inches. Okay, so let's copy that back over here. We're going to set this up as 2 inches. We're going to do the same thing over here. This is your 2 inches. And then the vertical distance here is that 0.18 inches. Great. And now this is still blue, so let's fix that up by adding an equal constraint between the size of this and the size of this. Perfect. We are missing an extra piece here though, which is that when we put the gearbox on here, it's going to bolt directly to the frame, but we actually need an access hole on the other side. So to do that, let's go back to this view, and we're actually going to draw in let's draw in an axis. So normally we would actually use a circle or something, or a slot, I guess. But for the purpose of this tutorial, to make it look really different on the other side, let's actually draw in a rectangle. I'm going to make these rectangles connected together by using this automatic constraint here. Let's see if we can get it to do one like this. And then we will just give it some we just have to add a bunch of arbitrary dimensions here. So I'm just going to make it like a 1/4 inch in each direction. And then we'll kind of make it look like a slot like this. Normally we would make sure that the tool fits through this hole. Okay, great. Now everything is black, so everything is constrained, and then we hit check mark here. So before we go and extrude this, I actually want to put in the rest of the holes. So let's actually start another new sketch. Great. Okay, and just like we did on the front extrude, we're going to put in this circle here. Going to dimension this. We're going to dimension that to the edge of the part to be that 1/2 inch here. And we can do the same trick that we did on the front tube. And we can use a constraint, which I believe is horizontal here, from this point to this point. Okay, that's not the right answer, so we're going to use the vertical constraint there. From this point to this point. So I just did Control Z to undo that. Okay, so now it lines up. So the linear pattern is supposed to be here, but I think I selected something by accident. So I'm going to do the arrow to select linear pattern. The other way that you could get to the tools is hitting the Search Tools button, hitting the Search Tools panel, and then you could actually look for linear pattern and then hit Enter. So we're going to just insert the parameters here. So that's 3 high, 0.5 inch spacing, 0.5 inch spacing this direction, and I think we said we need 59 holes going all the way out there. Right, just to the end of the tube like that. Okay, the reason I wanted to do these together is that if we just extruded this right now, we would have a conflict between the holes for the bearings and the holes for the pattern. So to get rid of that, one of the we can do, just like we did on the gusset, we can select a whole area of holes and right-click construction, and that will make those not extrude. So same thing when we get over here to like the mounts for the gearbox, we can take this whole, actually we can even select some more here. We can take this whole swath of holes, convert those all to construction, and those will not bother us now. Okay, we can select more here, convert these to construction as well. Great. I'm going to use this isometric corner here to jump into the isometric view and exit the sketch. So now we can take all these sketches that we made. Let's see what happens if we just try to extrude this. So we do extrude, solid, remove, and we wanted to do through all, but you can see that this isn't quite what we were expecting. So the bearing holes look fine, but this whole thing with the access holes and the actual bolt holes, that didn't quite work out. So we're going to X that out. And in this case, we will select exactly the items that we want to remove. So we're going to remove the bearing holes. So these are the through all components. So the bearings are going to appear on both sides. So we remove all the bearing holes. And then the inside, not that one. I actually want to get rid of specifically what I'm trying to select is actually I want to select the circle on its own without the box around it. Okay, so zooming in on a little bit. Seems to help actually selecting just that circle by itself. Okay, so I'm going to select each of the circles for the bearing holes and the bolt hole mounts. We're going to change that to through all, and you can see that that appears on both sides of the tube. Okay, so we solid remove all of these things. Great. We're also just going to get rid, take out the rest of those holes as well. So we extrude that as well. Solid remove through all. And if we check OK, now we have holes on both sides of the tube. We do face a little bit of an issue here where we need to get a tool inside of this tube in order to install the gearbox. So we need to go back and get our access holes, but we only want them on one side. So to do that, we'll go back to the sketch that has the access holes in it, which is sketch 5. I showed that again. And if we go to this extrude tool again, we do solid remove, and we select those two areas that we really wanted before. So you can see that by default, it's going to start at this face and take it out of both walls. If we only want it to come out of the far wall, what we can do is we can change the ultimate end condition here to through all. But then we can hit this checkbox for second end position. And we can then, you can either just have it like start, this is where it's actually going to start cutting away material from. So you can see that the second end is going this way right now, but if we click it, it will go the other way. So right now, you can see how it does not take material off until an inch in, and then it removes from the second wall. You can also use different options here, like up to face, which is actually from face. And then if you select the inside wall, it will start taking it away from the inside of the tube. So that way arbitrary numbers like changing the tube size doesn't impact how you extrude. And we can preview this and we can see that it's created a cutaway access on one side and the actual bolt holes on the other side. So we hit check mark and we can hide the sketch. And we can hide this sketch too. And now we have a drive tube. So it's got access holes on one side, got bolt holes on the other. And to get back our the rest of our stuff, we can now move the rollback bar all the way down to the end. And it should redraw that front tube like we had before. So this is good if we only wanted one copy of a drive tube, but I don't really want to do this much work to get the right side drive tube as well. In this case, it actually is kind of symmetrical. If we made more mount back here, then it could be made unsymmetrical. Let's just assume that we need to have a left and a right version. We can do that at this solid model point by just by using the mirror tool. So if we click into this, we can see that there's different options. We can use it to mirror geometry, you know, if you use the add or remove, but you can also use it with a new option, which will just create a totally new part. So it asks us, what do you want to mirror? So we would select the drive right tube, and then it asks us, which plane do you want to mirror it across? You could select this right plane, but it will literally make another copy. It'll make another copy of it kind of over here, which doesn't really help us think about you know, how these parts go together. So what we could do is actually draw ourselves a plane. So if we go up to if we jump into here and we look for plane, then we can actually make a copy of this right plane. Well, there's a couple ways to do it. We can actually, there's one type of plane that's literally called midplane. So if you use midplane and you select the middle point of here, it will actually put a plane through the middle of this extrude. Another way to do it is to do an offset plane, and we can take this plane that's like perpendicular to the front tube, and we could specify a distance, or we could specify a point. Like for example, we could use the midpoint here, and you can see that it's inserted a plane in the middle of this bar. So let's do that. They're basically all the same to create a midpoint plane. And now we can go back to our mirror tool, and we can mirror the drive right tube, have it make a new part, mirror it across this midpoint plane, and you wait a couple seconds, and now we have a copy of our drive tube with everything connected. Okay, and this is actually going to create a new part. Oh, I'm sorry. You can see that they all changed to the same color, so everything got merged together. If we edit the mirror and we actually make sure that it says new part, and then click check mark, it will actually show up as a separate part. Okay, here we go. So now you have part 4. It's this piece over here. If we rename it, we can give it the drive left tube. And now we have these two discrete parts. To demonstrate why this mirror is really powerful, if we go back into the drive tube and we modify, let's say that we modify this and we wanted to add a second gearbox mount location, right? So this is actually something we have drawn in before. So I'm going to use that automatic snap, and then I'll make these equal. And then we'll draw in our spacing. Okay, so now I made another copy of these bolt hole mounts for the gearbox. And I probably also need to go edit the extrudes that go with that. So like we would want to extrude a copy of those circles. So we would need to zoom in here and take these two circles out, right? And we also probably wish to take away, we probably want to take away some of the oops. So I got lost on the part here. So we probably, it's because the sketch is hidden. So if I unhide the sketch, then you can see where, you can see that here we hid some of the holes. So I'm going to do the same thing. I'm going to take these holes over here and I'm going to convert these to, it didn't quite select the edge of it, so I'm just going to zoom in and then I can right click and hit construction. And now when I click check out of this sketch, these holes will not be, just like over here, these holes aren't actually drilled out. When I modified the second set of holes, it did take away some of my geometry for the extrude, so I'm just going to put that back in here. And the reason to add that second gearbox mount is, so for example, we did that in 2019 because we weren't sure in the middle of the season whether the motors were going to go in the middle or the back. That creates these asymmetrical drive tubes. But what's great about having the mirrored part is that this part on the, the left drive tube here picks up all of the changes that you make to the right drive tube. So now these are true mirrored parts.